Earth Science video coming at you. This is Norris Teaches Science today with another Earth Science Edition video with me, Mr. Norris, and today we're going to talk about groundwater. So the goal of this video is that I can discuss groundwater formation and factors that affect it. So what is groundwater? Groundwater is water that is below the surface. And about 50% of water used by the public is groundwater. Um, where I live, we have a lot of wells, so we do use a lot of groundwater. But you can see in this picture here where groundwater is. It's actually down in the soil. Now, how does water become groundwater? Well, you have three things you have to deal with when you deal with the water becoming it. Permeability, which is how easily water can pass through connecting pores, and those pores are in the soil. You got porosity, the percentage of pores that are in the soil and the rock. And just so you know, remember when we talked about soil, we had sand, silt, and clay. Clay has the smallest percentage of pore because clay is not permeable. It's like a layer where water can't get through. Water can usually get through layers of sand and layers of silt, reaches clay. It's really hard for it to get through. And the other thing is infiltration. That's actually the water going through the soil. That's the process. And all these work together so that water can get into the groundwater. Now, if we look at groundwater layers, and I would probably pause right now, maybe draw a little sketch of the picture over here, label your picture so you can study. You can see the blue right here, that's all groundwater. All right, so the first thing is the water table, and you can see that right here. I'm highlighting it. That's the water table. It is the border between no water and water in soil and rock. You can see no water up here, water down here. The water table is the border. And when people say the water table is dropping, that means there's less water in the groundwater and more soil without water. The zone of aeration is above the water table. Water passes through it, but that's not where the groundwater is going to be located. Zone of saturation, if you think of the word saturation, you think of water, you think of being waterlogged, is the area where the soil, sediment, and rocks are saturated with water. You can see that right here. And groundwater is, of course, all the water in the zone of saturation. All this blue over here, is the groundwater, the water that is fresh water and can be used for drinking. When we talk about groundwater, we talk about things called aquifers. They're underground layers of water bearing permeable rock, gravel, sand, or silt from which groundwater can be extracted. So you can see the aquifers here. You can have confined aquifers or unconfined aquifers. Confined aquifers means that there's impermeable material above and below the aquifer. And down here, I'm going to circle it. Here's a confined aquifer. We have clay above it and we have bedrock below it. So it's not reaching the surface at all on its own. Unconfined means that it can interact with the surface. You can see the unconfined right here. And it can interact with the stream. It can interact with the surface on its own. You also have something called artesian aquifers, but they also sometimes call them artesian wells, in which I'm going to talk right here. A well is we drill a hole into the ground, into the zone of saturation, so we can take out the water. But an artesian well, this is where groundwater rises on its own pressure. You don't have to use electricity, it just comes up on its own. Now, there are some problems with using wells. Pumping out water from wells, from the groundwater, does lower the water table. Groundwater takes forever to recharge because it's all based off how much precipitation you get to an area. And there's also something called the cone of depression. So you can see here, cone of depression. When you withdraw water, you get this little downward spot. And so you have to pace your wells out a certain amount so that your wells can all work. But say if there was a house here and a house here and a house here, it would start to make more and more cones of depression where it would be hard to use the well. All right, so when the groundwater meets and surface meet, it does happen. You know, those unconfined aquifers. You can get lakes and ponds to form. You can get geysers to form. You can get hot springs to form, and then you can just get normal springs. The difference between a spring and a hot spring is that a hot spring has been heated with stuff inside the earth, so it is at a different temperature. Okay, and so we can use all these different things for different reasons, like lakes and ponds for recreation, fishing, you know, just playing along. Or we can probably take some water out of it as a reservoir and start and use it for drinking water in all of our waters in our house. Features that groundwater can create. One is caverns. These are naturally formed underground chambers when water is withdrawn, leaving it empty. So water is in there. It kind of takes away some of the minerals and deposits in there through erosion, and it leaves this little empty space. Well, when water retreats out of it, you get a cavern. That's kind of like a cave. It can form at or below the water table by erosion. Another one is sinkholes, a depression, which is a depression produced by groundwater removing soluble rock. And this is usually within limestone. So water is in limestone, the limestone dissolves with the water, and it leaves an empty space. And then the surface above the empty space is just too heavy and it just collapses. Florida is known big for their sinkholes because of their limestone bedrock that they have. And that's some problems with groundwater. This is stuff that can happen. Some of it makes it really unusable. But the first thing is withdrawing water for agriculture. Remember, most of our use for fresh water, is agriculture. But withdrawing the groundwater for agriculture can lower the water table, even get to the point you deplete the groundwater entirely. You can have leaching of toxic metals, so as the water is infiltrating down the soil and it's going into the groundwater, it can pick up toxic metals and bring that to the groundwater. That makes the groundwater contaminated or polluted. It can't be used. Some of these toxic metals are like arsenic, cadmium, lead, radon. They can get in there, and if you ingest them, it can cause big problems. And you also have something called saltwater intrusion. The definition of that is when salt water from the ocean enters the groundwater near coastal areas. So remember, groundwater is fresh, and the ocean is salt water. And if you're near the coast and you're withdrawing water from a well, you're releasing the pressure on the groundwater, allowing salt water to come in. And if salt water comes in, we cannot drink salt water. We need fresh water to drink. And if you irrigate your um, crops with salt water, it can cause crops to die. You can salt your fields, and you cannot use your fields for a while. So it becomes a problem. But this is a little bit about groundwater. I hope you learned a little bit today. I hope you learned something. This is Miss Norris. I'm out for this video.